Hi, I'm Raghuveer Parthasarathy. I'm a physics professor here at the University of Oregon. There are about 30 of us physics professors, and we are generally located in this building, which I'm showing in the background of the slide, which is one of the most beautiful ones on the University of Oregon campus, and hopefully someday you'll get to see it in person. So I've been a professor here at UO since 2006, and I live in Eugene along with my wife and two kids, and you can see pictures of them over here. As you might guess from the pictures, when I'm not doing physics, I like to go for hikes. I also like to draw and paint. But I'm not going to tell you about that today. I'm going to tell you a bit about what we in physics do and why we find it so exciting. And most summers, actually, I co-run a sail camp that's actually a combination of things from the physics department and the human physiology department. And we do activities that bring these two things together. It's a lot of fun. But one of our goals really is to convey a sense of what is physics and why is it that so many of us get so excited about it. Now, I'm going to put up one of the most difficult questions in physics, so get ready. One of the most difficult questions in the entire field, which is, what is physics? So it turns out that physics is actually a really hard thing to define. It's a big umbrella of a lot of different stuff. And I thought I'd give you a glimpse of what physics is by showing a couple of the things that it ranges between. And we're going to talk about this more actually in an activity tomorrow as well. So physics explores a lot of stuff. It explores some really small things. And this includes, for example, stuff like subatomic particles. And there are a lot of physicists, for example, Professor Laura Gianti in our department, who work on these gigantic experiments colliding beams of particles together, typically at particle accelerators located in various parts of the world, where you smash particles into one another and look at the properties of the fragments that come out, and from that determine what are the fundamental building blocks of matter. So we're looking at really, really small things like subatomic particles. But physics also explores really, really big things. And this includes, for example, things like gravitational waves. And here's a picture of another physics professor in our department, Ben Farr. And he's part of a large group that studies gravitational waves that emanate from things like black holes running into each other or neutron stars colliding. And just in the last few years, they've made amazing progress in being able to detect these astrophysical events. So we have really small things, we have really big things. And of course, we have the stuff in between, and there's a lot of that as well. And this can include things like stuff that UO physics professor Benjamin Alemán does, where he builds really, really small mechanical and electrical devices. For example, this little trampoline you see here is smaller than a blood cell, and its vibrations can actually detect light. And he's building things like this to make new types of sensors and detectors and that kind of thing. Here's another UO professor, Eric Corwin, whose photo I forgot to put up, sorry. Eric's lab looks at things like glasses. And we've seen, everybody sees glass all the time. There's glass on the screen that you're looking at this on. And the question of what makes a glass and not a liquid or a solid ends up being one of the most difficult questions in materials physics that people have tried to answer and still don't have an answer to. And Eric does experiments and also a lot of computational simulations to try to get at what are the arrangements between the molecules in a glass that give them weird properties. This also includes my lab, and I'll say more about this tomorrow as well. But we look at questions like, how do bacteria make use of laws of physics? How do these microscopic organisms move around, build structures, and do those sorts of things? Now, to get at these questions, we do another thing that physicists like to do a lot, which is build things. So my lab actually builds new types of microscopes. There's me with some lasers and lenses and stuff like that. We build new types of microscopes to do 3D imaging, like very, very small stuff. So we've got big things, small things, everything in between, and really trying to get at the sense of, what are the fundamental laws that govern all of this stuff. Now, we're going to look at this more tomorrow, and you're going to meet other physics faculty as well, and we're going to give little tidbits of the kind of things that we're interested in. And we're also going to ask you to discuss the question, what do all these bizarre things have in common? Which there's no right answer to, but which is a really fun thing to talk about. So those of us who are physics professors at the University of Oregon, we really do two different things. One, which I've been telling you a little bit about, is research. That is, doing experiments and stuff to probe these questions. And when I say we do research, it's not actually just me, but me and students, undergraduate students, so college students, graduate students, and so on, all working together, like in labs, to design and build and carry out these experiments. And that's really a lot of fun working in these small kind of intense groups and looking at this stuff. But we also do the thing that you're probably more familiar with, which is like classes. We teach classes. So if you were a physics major here at UO, you would take classes like this lab class that I'm showing a picture of here. There's really kind of a broad variety of classes. There's lecture classes where you're like sitting in chairs in a room at a lecture. There's lab classes where you're doing things and building things. And in physics especially, some of the higher level lab classes are really a lot of fun. There's sort of core classes on the basic fundamental things that make up all of physics, like electromagnetism, quantum mechanics, and so on. And then a lot of additional classes on other areas like optics or computational tools and things like that. There's also a lot of math. Physics, one of the reasons it's been so powerful and successful as a topic is that we really dive into, can we really, with actual numbers and predictions and so on, describe and understand these things? So it's a challenging major. It has a well-deserved reputation for being rather difficult, but also a well-deserved reputation for being very rewarding and satisfying. There's a low student to faculty ratio, and one of the neat consequences of that is that there's a lot of opportunities for doing research and other kinds of exciting things while you're a student. Here's a picture of one of the students who worked in my lab, Hillary Ross, giving a good thumbs up there. So why would you study physics? Well, I'm biased, of course, but it is super interesting. And there's a lot of variety, as we've also seen as well. Another really interesting thing is that it's fundamental, but it's also very practical. It touches on questions like, how can we build new materials and new devices that can be useful for like medical fields or energy or all kinds of things like that. So whenever you go to a hospital and get an MRI or a CAT scan or X-rays or things like that, those are actually all techniques that were developed by physicists. Also, as I mentioned, things like new sources of renewable energy and things like that are also things that physicists explore. I actually teach a course on physics and energy in the environment that you can ask me about later if you like. So also coming to the question of like why major in physics, physics majors tend to be very well employed. Which is kind of interesting because many of the jobs they end up in are not sort of typically physics ones. They can be more medical or more public policy or all kinds of things like that. But they end up being hired at quite high rates. The employment rates tend to be around like 95% or so. And these can be in many, many different things. And to give a little bit of a sense of that, here's a question for you all. So as you may or may not know, if you want to go to medical school, you take an exam, typically in your last year of college, called the MCAT, the Medical College Admissions Test. So of the majors that I'm going to show you about in a moment, you can try to guess which one gets the highest scores on the MCAT exam. And your options are psychology, biology, chemistry, physics, engineering. Ponder that for a bit. We'll turn on the polling thing. Okay, so choose A, B, C, D, or E. Which of these students with these majors get the highest scores on the MCAT? Good, we've gotten everybody's scores, so you can see that. And next question, I'm going to clear off that one. Which gets the lowest scores of those five? Go ahead and click in. Oh, sorry, same choices. Okay, go ahead and click in. So let us see. Well, probably nobody's terribly surprised that of those five, since I'm the one giving this talk, it is in fact physics. So physics ranks number 2, at least in 2013, of MCAT scores. I couldn't find more recent data, unfortunately. But yeah, physics just generally tends to rank very high on this. We can chat about that later, like what the reasons might be. And of these majors, interestingly, the lowest of those five is in fact biology. Same kind of a question, but now for the LSAT, the law school admissions test, which one takes before going to law school. Which of these get the highest scores? And the options are pre-law, psychology, political science, physics, and engineering. Okay. Ponder that for a second, then you can click in. And same deal, of these 5, the lowest. Okay, let's see. Cool, so again, it should not come as a shock to anybody that of those 5, physics is the highest on the list. And, oops, sorry, I clicked too fast. Pre-law, incidentally, was the lowest. And what this really highlights, again, is that the training that studying physics provides is useful, of course, for understanding physics, but it also ends up being really useful for understanding all sorts of other things about how the world works, even things like medicine and law and so on, because it is a very kind of problem-solving focused, kind of intense major. Yeah, and we can talk about that more at later points during the week as well. So tomorrow what we're going to do is meet 6 faculty for what we're calling a physics slam, where we give like really short 3-minute talks and then discuss them, especially with an eye to the question of what ties all of this together. So I'd be happy to take any questions now and at later points throughout the week. So thank you very much.